Okay, so let's look at this data set I have here. And this is 1,000 dice that I've bought and I put them in a bucket, and I have different colors and I weighed them all, right? So these are the weights in grams. So let's say somebody looked at my dice bucket and they said, I think about half of your dice are white. Okay, so they believe that half of my dice are white. So in this example, the null hypothesis would be that half of the dice are white. So we would use p equals 0.5 again. So the alternative hypothesis would be that it's just not equal to that. It's something else. And let's use a 0.05 significance level. So that would mean since we have a not equal to, the confidence level would be 1 minus the significance level. So that would be a 95% confidence interval. Okay. So now we want to take a sample. So let's say we dipped out some dice. I'm going to do that by using data sample. I'm going to sample the colors. Let's do 100 dice. So StatCrunch picked out 100 different dice, and it just picked the colors, right? And then I want to know what proportion of my dice are white. So I'm going to go to stat tables frequency. Going to pick sample color. And in my sample, I got 34 white dice out of 100. That's a relative frequency of 0.34. So my sample proportion of white dice is 0.34. So I'm going to say that my p hat is 0.34, right? And I had 100, I picked 100 dice. So now I want to bootstrap my, I want to bootstrap the sample proportion to get an estimate for the population proportion of white dice. And I'm going to use this sample where I got 34 out of 100 that were white. So let me pick applets, resampling. I want to bootstrap a statistic. I'm going to use proportion. I got 34 white dice out of 100. And I'm going to run the bootstrap simulation 10,000 times. You could get by with less. I just like using 10,000. And I'm going to create a confidence interval that's a 95% interval. So that would be 2.5 to 97.5. So that would be 0.25 to 0.44. So my confidence interval, 0.25 to 0.44 with 95% confidence. So is 0.5 in this interval? It's not, right? So we're 95% confident that the population proportion is between 0.25 and 0.44. So the assumption that p is equal to 0.5, we think it's likely it's not correct. So we're going to reject the null hypothesis. And our conclusion is that there is sufficient evidence or enough evidence to support the claim that the population proportion of white dice is not equal to 0.5, the alternative hypothesis. So I have all of the colors of all the dice in the bucket. So if I just do my frequency table on all the colors, we see that the population proportion of white dice is actually 0.3. It's 30%, which is in my interval, right? My interval contains that 0.3. So the confidence interval worked, and it's not equal to 0.5, right? So this is a case where I could actually check to see if our confidence interval or if our hypothesis test actually worked. So we're pretending that we don't have this entire data set, that we are just scooping dice out of the bucket, and we can figure out something from the sample. Okay, now let's do another test with population mean. So let's say that you looked at the dice and you said, I think the average dice is going to weigh about 4.6 grams. So our null hypothesis would be that the mean is equal to 4.6 grams. So I didn't say anything about is it less or greater. I just said equals. So the alternative hypothesis would be not equal to. And let's use a significance level of 0.05 again. So that would mean our confidence level is 95%, 0.95. So let's take a sample. Let's take 100 again. This time I'm going to sample the weights. I need 100 of the weights. So here I've got my sample of 100 weights. If I do summary stats on sample weight and pick the mean, that'll tell me the sample mean. So the sample mean is 4.6363. So I took a sample of 100, and I got a sample mean that was 4.6363. That is not 4.6, but it's close. So the question is it close enough? Or is it far away enough for us to say we don't believe it's 4.6? So let's take a bootstrapped confidence interval. So I'm going to go to applets, resampling, bootstrap a statistic. I'm going to use, from the data table here, I'm going to select the sample weights, and I'm going to do the mean. You can do all these others too, but we're just going to focus on the mean and the proportion. So for the mean, I'm going to take 10,000 bootstrap samples and find the middle 95% of the sample means, and I get 4.53 to 4.75 using the 2.5th percentile and the 97.5th percentile. So 4.53 to 4.57. I don't think that's right. 4.75. I'll switch those two numbers. So 4.75. Okay. So we're 95% sure that the population mean is between 4.53 and 4.75. That does not contradict our assumption that the mean is 4.6. So I have weighed every dice, but you have not, right? So you're just trying to guess. So you take your sample, you scoop dice out of the bucket, you weigh all the dice in your sample, and you make a confidence interval based on the sample. So you don't know what the population mean of the dice is, but you guessed it was 4.6, and our confidence interval does not contradict that. So we're going to say, since this is inside the interval, we're going to not reject. So fail to reject, or do not reject. the null hypothesis. That means we don't have enough evidence to support the alternative hypothesis. So it could be that it's not 4.6, okay, but we don't have enough evidence to say that, right? Now I do have the, all the weights in a population here. So we could take the mean of all the weights and we find that it's actually 4.64. So it's not equal to 4.6. It's still pretty close, but this would be an example of a type 2 error, right? So the null hypothesis was actually false. We didn't have enough evidence to say it was false. So that was a type 2 error. But still pretty close, and our sample mean was actually really close to the population mean.